the Greater San Diego Science and Engineering Fair as a STEM research contest accepts both science and engineering projects. Science projects typically include an experiment which follows a fairly set structure with mandatory steps. However, engineering projects follow a design, then improvement, then redesign format used in industry to create products, which is more flexible. Today, I will be going over the process for creating a successful engineering project. First, you need to find a real-world problem that needs to be solved or improved upon using something you can design and build, an engineering solution. For ideas, you can think about what you do or use every day, or look around your neighborhood. Is there something that can be made safer, or something that will make your work easier or life easier? You can also talk to family or friends for ideas. Is there something that they do that is awkward or inconvenient? Maybe you want to do a project on something you're concerned about, like global warming. After choosing an idea, start by researching existing solutions to get an idea of what has already been tried. Once you have your purpose, you need to develop a solution that can be built with materials you have on hand or can easily obtain. Make sure you determine specific objectives that your design must meet and possible constraints. Then design your solution. Make a list of materials you will need and sketch or make a drawing so you have a plan before moving forward. After you have a plan, it is time to start building. As you build, you will need to troubleshoot and refine your design. No plan is perfect the first time, and it may take several attempts before you devise a solution to meet all the objectives. There are several ways to troubleshoot your design. The first is to build a prototype that you test to find any problems. Then, you revise your design and build and test an improved version. This can include completely building a new prototype if it looks like no amount of modifications will meet the design objective. Or, you can improve only certain parts. You may find that two pieces don't fit together, or you need an extra piece to meet the objective. Maybe a wheel does not turn properly, or a piece is leaking. You then find the problem and fix it without rebuilding the rest of the design. These same troubleshooting methods can be applied to fix computer programs or electrical circuits. Be aware that you will probably use more than one of these methods for fixing problems with your design. When your final design is complete, you need to test it and prove that your design meets the design objectives. Ideally, you test it in real-life situations by showing how your design works in an environment where it would be used by people who are your intended users. In some cases, a working prototype which meets design specifications is all that is necessary. An example would be a machine which folds paper. The only goal of the machine is to successfully fold the paper. In other engineering projects, quantitative data can be gathered. Different designs of seawalls can be tested and data gathered to determine which one reduces the severity of a tsunami the most. When your project is complete, you need to write it up for the fair. You'll have a purpose statement, design objectives, which replace hypothesis, materials, and procedure, which is the design process. After that, your results section may look different than that of a science project. It will show the various designs and how each one is an improved version of the previous one. Include an explanation on how the parts of your design work and why they are necessary to your design. Describe each of the challenges you encountered and how you solved them. If your project included quantitative data, be sure to include it and the analysis of the data. You may also want to include pictures or videos showing the functionality of your design. Thank you for watching, and I hope to see you at the fair.